To convert from radians, what I would do is I'm going to turn this into a fraction. And I'm going to put degrees on bottom because I want those to cancel out. I want degrees to cancel out. So I have degrees on top and bottom. They'll cancel out. Well, the conversion we can use, just like 12 inches are in 1 foot, we have 180 degrees in how many radians? 1 pi. So that's going to equal to 15 pi divided by 180. And if you look at the board, you go, that's not on there. So you would have to simplify in this case. If you simplified correctly, you'd end up with A, which would be 43 pi over 36. Next one looks awfully the same. We do the exact same thing where we put 180 degrees on bottom and we put pi on top. We might have negative 22 pi over 180. Now, I'm not a huge simplifying person. If it looks really complicated, I'm not really worried, but we should see at least 2 goes into both of those. That is something I could expect you to do, to see that 2 goes into both of those. And so we should have at least a negative 11 pi over 90. In fact, that's where we would end. When we go from radians to degrees, we have radians on top, so that means I need radians on bottom. Our radians for conversions is going to be our pi. On top, we're going to have 180 degrees. Now, I said when you are converting to degrees, we don't keep pi in the answer because I don't want like 12 pi degrees. That's very confusing to write. So this means you would plug this in your calculator, right? 14 pi times 1/8. Well, we can actually cancel out the pi's. You don't even have to do that. And we would just end up with, is it 280?
Yeah.
Cool, 280 degrees. If this was on the test that just says convert 7. How do we know that it's a radian? Because there's no degree symbol, so we automatically know it is in fact a radian. So radian, this is the hardest one to remember because we do have to put radians on the bottom. We don't see the pi's cancel out, unfortunately. And we have 180 degrees. This is definitely one we have to put in our calculator because the radian or the pi's don't cancel out. So we put that in our calculator and we should end up with about 401.1 degrees. And then if we look at the board, that would have been C. Most of us did answer C. A couple stragglers didn't, but that's okay. I think a lot of it had to do with you weren't quite sure what was happening. You were scrambling for your cards. So let's get them right every single time we have kind of these spell works. It doesn't happen every single day, but when you see one, that's what I'm doing. I'm checking your knowledge. All right, questions on any of these? Then let's do homework questions. Yeah, what do you got, Mike? Number 7. Is that the last one? All right, number 7 says, find the linear velocity for a point on the surface of the Earth that is 1 mile from the North Pole. So there's a little bit of curve, but let's go ahead and just look at what's happening here. So let's draw Earth looking down at it. And in the very center is our North Pole. That's what we're looking down on. There's our North Pole, and we are, what did I say? We are 1 mile from the North Pole. So we'll be this pink dot here, and that's exactly 1 mile around. Now, if you're looking down on the Earth, without going too into detail of like there's an angle of the Earth, we're just going to say that spins around and makes a circle. So this goes around and makes a circle. Now, we're looking for the linear velocity, correct? Which means we're going to start out with revolutions per some time. We'll turn that into radians, and then we'll multiply by the well, what's the radius here? 1. So whatever we get for angular velocity is pretty much our linear velocity because I'm going to multiply by 1. So we are going to start with revolutions per some time. So we'll get our angular velocity first. What do we know about the Earth? You were saying something? 24 hours. You'll do 1 revolution in 24 hours because that's a day. It'd be 1 over 24 revolutions-wise. 1 revolution. So much, yeah, just turn it off. Yeah. Not 2 pi, I'm sorry, per 24 hours. And we want linear velocity on a point at Earth, 1 mile. So it doesn't even say what units it needs to be in. We'll do miles per hour, I guess. So to turn that into radians, do you remember how to turn that into radians then? Yep. 2 pi over 1 revolution. Our revolutions cancel out. And we do have 2 pi over 24, which is actually just going to be pi over 12. And we will have pi. We'll get miles when we turn it to linear velocity. Because right now we really have pi radians per 12 hours. Does that make sense so far? So now when we put the radius in, that's going to change the units. Because you might have just skipped to the end here, which is fine because you realize you're multiplying by 1. But to turn it into linear velocity, we would go, okay, the radius is 1 mile times that pi radians over 12 hours. 1 mile is actually 1 radius, so we could, if we wanted to, see the radius cancel out. Then we'd plug that in our calculator because we want an approximation. I don't want pi in my answer. And we end up with, 0.26 miles per hour. Yeah?
So I did mine differently. I put it in miles per day.
Okay.
And it's the same answer. I just divided by 24.
Hey, cool.
Would that count?
Yes, it would, because I didn't put anything in that direction that says what you have to put the linear velocity in. Notice there's no, if I said you have to have linear velocity in miles per hour, then you'd have to do it.
Okay.
Yep, your answer is fine. Yep. So it's kind of slow, right? Well, that's because you're really close to the top. Do you think we're going that slow? No, because the Earth is pretty wide. We could figure that out, but we're going a lot faster than 0.26 miles per hour. It's also why if you go very, very north, the sun barely moves as you're going because not a lot's happening. All right, other questions on the homework? We good on that then? Yeah. Okay. Other questions on the homework going once? Going twice? All right, let's complete our units. Well, let's add sine and cosine first. So a quick trig review. When we are talking about trig, we're going to focus on that SOHCAHTOA. We'll kind of get away from that because we're just going to have sine of certain angles and we're going to know the values of them. But just a rehash, SOHCAHTOA tells you sine is opposite over hypotenuse. It tells you cosine is your ka, which is adjacent over hypotenuse. And finally, your tangent is toa, that's opposite over adjacent. And that's all we need to know about that. Because we're going to figure out how these angles are actually calculated. We're not going to calculate the angles every single time, but at least we can see how they're calculated right now. All right, so starting to build our unit circle. Trigonometric functions on the unit circle. A unit circle is a circle with a 1 for its radius. So 1 for its radius, so it's radius of 1. Radius of 1 is the key to it. So if I was to draw the unit circle, you know that big one you drew a bunch of times last year? It's on the xy plane. It is always on the xy plane, always. We just don't always draw it that way because it's always going to be a circle that goes from basically -1 to 1s on both of these. So if you knew nothing about the unit circle, if you don't remember any of it from last year, you actually already know 4 key points. This is just an xy value of 1 x value, 0 up or down. So if I told you to fill out a unit circle right now and you didn't remember any of the values, you should at least know 4 of them from basic geometry. And I guess a little bit of algebra because we do have a graph. We would remember that point 1, 0. We could put this point here, 0, 1. We could put this point here, which is -1, 0. And we can have the point 0, -1. These 4 points are the most frustrated ones I have when people can't fill out the unit circle. When they get the other stuff right and they flip up all of these. Because these are just reading a graph. So don't get bogged down and straight up, because I hate rote memorization. That allows you to flip stuff. Understand why values are the way they are. And the way we're going to do this we have to have this point correct. This one point will get you the rest of your unit circle. This one point is going to be the one I'll teach you to use to get to the rest of the unit circle. So you have to have it right, otherwise all your values are messed up. All right, so that's a unit circle. Well, we're going to compare all the angles in degrees and radians, and we're going to use it to find exact values of the 6 trig ratios. So before we do that, we're going to go ahead and we're going to fill in a little triangle. Because your unit circle is built up of a whole bunch of triangles. Obviously, this one's not a triangle because it's flattened. This one's flattened, but we should be able to figure out those points. Now, that triangle leads to a very specific point. It leads to, well, if I go right x units and I go up y units, this point is going to be x, comma y. That's it. It's just x, comma y. It's left or right x units. It's up or down y units. Hey, Mercer. Good. How you doing? Take that. All right. Yep. All right. Then what I'm going to do is I'm going to put a little angle in that bottom left-hand corner. That's a terrible angle. That's theta somehow. Let's make that a little bigger. I got theta right here. Here's an angle. This triangle right here, we actually know this length right here. How do I know the hypotenuse of this? It's the radius. And what's the radius right now of any single point on this unit circle? 1. That's the point of it. A radius of 1. So this needs to be 1. Well, that actually allows us to solve for our x and y values at any angle that we have. Because let's say I want to find the x value. If I want to find the x value, what we're going to use is, I'm going to notice how the x is on the adjacent side. Adjacent means it's attached to the angle. And cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Let me actually change this real quick. So we're going to say, okay, if I had cosine of an angle equals adjacent over hypotenuse, that would be x over 1. We really just have x equals cosine theta. This is going to show up a ton in trig, not just in the unit circle. We're going to use that for imaginary numbers. We're going to use, or complex numbers. We're going to use that for polar plane. If you understand this concept, how I came up with this, everything else becomes really, really easy. All right, and the last thing is, if I did sine, why did I put sine? If I put sine of theta, sine is so, which is opposite, which is our y value, over our hypotenuse, which is 1. So sine would equal y over 1, but much more easily, y equals sine of theta.
And that's if the radius is 1.
Say that again?
And that's if the radius is 1.
That's if the radius is 1. We are going to talk about other circles where this is an r. That's when we get to complex numbers and stuff, but we can kind of do the same thing. The only thing is this would have a radius in front of it, but it still works out the same. This works if there's a 1. What that means to you is if you know the x value here, you actually know the cosine of this angle. So if this is pi over 2, then cosine of whatever angle this is equals pi over 2. That allows us to build our entire unit circle up, and that's what we're going to do next. So if you didn't have those notes down, they're right here. Basically, xy gives you your cosine of the angle and your sine of that angle. They're equal to each other. All right, so that gives us the start of our first kind of sector of our circle here, our quadrant 1. Now, I already said that we should be able to label the ones on the x and the y axes. That's not something you have to figure out. That's just from the graph. Since our radius is 1, this bottom point right here, and I'm going to label it here, is the point 1 right, up 0. And the one that's vertical is 0 left or right, up 1. You got to know those. You gotta know those. All right, zooming in on those real quick. So, I am gonna note that this is 90 degrees. Well, these are the key areas we need to know. We need to know this tiny black one is 30 degrees. Our next one is going to be that 45 degrees. And that last one is going to be 60 degrees. Now, I think I'm going to jump right into the point in how we read that. We could go back to geometry and actually solve for these, because I can find the cosine of 30 degrees with a radius of 1. But I'm going to go ahead and assume that we did all that last year, so we're not going to spend a whole bunch of time on that. We're going to jump right to the point that's given here. This is going to match up with the point y value 1/2, x value square root of 3 over 2. And if you noticed, I filled out my y value first. I did that for a particular reason. That's what we're going to learn when we fill a whole unit circle. So what I want to point to here is that point actually tells you that this distance here, let's not put this, is actually square root of 3 over 2 right. If you go square root of 3 over 2 right, you go up 1/2. And if you remember, your radius is 1. So if you took the cosine of 30, the cosine of 30 would equal square root of 3 over 2 over 1, which is right here. If you took the sine of this, sine of 30 degrees would equal the 1/2 over 1, which is your 1/2. So if I asked for the cosine of 30 degrees right now, here's what you do. You'd say it's this value right here. This is the cosine of 30 degrees. They're equal to each other. If you plugged in cosine of 30 degrees into your calculator, you'd get square root of 3 over 2. Depending on how your calculator does it, it might actually give you square root of 3 over 2, or it might give you the decimal approximation. Making sure you're in the correct mode. For your calculators, there's a mode button.
Yeah, mine does the decimal instead of the actual.
Most of them will do if you have like an 89, like a really fancy one, it'll give you the fraction. Some of them will give you the fraction. But because it's a square root, it's a very complex thing for your calculator to have to do, so most of them won't do that. Do I know how to fix that? You can't fix that.
Okay.
It will always give you a decimal unless you have like a really high end, like I'm talking like an 89 or above calculator. Then sometimes those will give it, because it's too complex for that.
Interesting. Okay.
Which means you have to memorize the unit circle. You can't just put decimals in.
Yeah.
All right. And then if I put in my calculator sine of 30 degrees, this one should be easier. If you typed in sine of 30 degrees, you should get out 0.5. Whose calculator does not get out 0.5? If you type in sine of 30, you should get 0.5 out. Yours does not? Oh, you have a phone.
I don't have it, but I know that mine
mine
doesn't like decimals for some reason. It always does everything in fractions.
In a fraction, so you get 1/2 out. Yep. It would give this in a decimal, though, most likely. Yeah.
So wait.
Do you get something weird out?
No, like how do you put it into fractions again?
Oh, let's just go second. We're in degrees, second quit. Let's just type in sine of 30 degrees, hit enter. Most likely it'll give it into that, but you can now hit your math button and you can turn it into a fraction. I would not put it in a mode where it's always fraction, because decimals a lot of times are what you need to do when you're doing dividing and stuff. But that will not work for this one. Your calculators will not spit out square root of 3 over 2. If they did, this would be super easy, because you just plug this in and have your whole unit circle. All right, let's continue around with this quadrant. The rest of this quadrant is then going to be, our next point is, does anyone remember what our next point is?
It's like 2 over something.
2 over something. Well,
And then the other one's square root of 2.
yeah, we have 2 over something, but it's square root of 2 over 2. So you knew there's 2's involved. Here's the nice thing about the unit circle. If you get this first one right, To get the third one at 60 degrees, you just flip your x and y values. So your third one is going to be 1/2 and square root of 3 over 2. What I'm going to point out, we're going to fill out our unit circle in a little bit. We're going to go through some problems. We'll fill out our unit circle. This is how we're going to fill out our unit circle, and we'll do it all together. Look at your sine values or your y values. See this 0? Yeah. Sine goes 0, 1, 2, 3. Everything in the numerator has square roots on it. The 1 is square rooted, but we don't put a square root of 1 because it equals 1. And everything's over 2. If you remember the fact that sine goes 0, 1, 2, 3, you then have your whole unit circle. Because it goes 0, 1, 2, 3, 3, 2, 1, 0, 1, 2, 3, 3, 2, 1, back to 0. So I always fill out my sine first, and then we do our cosine. But we'll do that all together in a second. First, let's talk about reading the unit circle. So this says, find the exact values of sine and cosine. So I have it in degrees, and I have it in radians. So I have the sine of 0 degrees equals the sine of 0. What you need to do is find on your chart, where is 0 degrees? Well, 0 degrees is just the x-axis. And as a reminder, your y value is your sine value. So would we pick the 1 or the 0 for sine of 0? 0. We'd pick the 0. What's the cosine of 0? 1. So on that one, we could say the sine of 0 equals the sine of 0 radians, which equals 0. Cosine of 0 equals the cosine of 0 radians, which equals 1. Now the sine of 30 degrees, that's our first tick. This is where it's great to have your unit circle filled out. So the sine of 30 degrees is exactly the same thing as sine of pi over 6. Then we go to our unit circle and we find 30 degrees, or pi over 6, which will be on our unit circle. We go out here, we find our y value, which is 1/2. And we go, oh, that just equals 1/2. That's the radian version of it. It's what we filled out yesterday, the unit circle with radians.
Oh, okay,
Yeah.
So, okay.
So the cosine of 30 degrees is the exact same thing as the cosine of pi over 6, because pi over 6 is 30 degrees. They're equal to each other. And that's going to be your square root of 3 over 2. I want you to take a second and fill out the rest of these. We're going to take a second and we're going to fill out the rest of those. So I need to know what the cosine of 45 degrees is, the sine of 45. I also want the radian versions of those. So you might have to go to your radian sheet. You might want to just write it on that first quadrant. Okay, let's all refocus. If you're not done, that's okay. Let's just go through because I want to make sure we get to our units, building our unit circle. So we should have said sine of 45 equals sine of pi over 4, which equals square root of 2 over 2. The nice thing is cosine is the same, square root of 2 over 2. Sine of 60 is going to be our pi over 3, which is going to be a sine of square root of 3 over 2. We'll have a cosine equaling 1/2. 90 is our sine of pi over 2, which equals 1. Cosine of 90 equals that 0, which is still that pi over 2. Any questions on any of those values, or kind of how to read the unit circle? So reading the unit circle should be okay. It's just cosine then sine. You just got to make sure that's right. But the key on the assessment is going to be, can you fill out your unit circle correctly? Because if it's incorrect, you're going to constantly read it incorrectly. So let's talk about filling out our unit circle. Before we fill out our unit circle, we have to learn a rule. And that is, what's positive in what quadrants? So in quadrant 1, every trig function is positive. They're all positive. In quadrant 2, sine is positive. Everything else is negative. So that means cosine and tangent are negative. In quadrant 3, tangent is positive. We haven't even talked about that. So that means sine and cosine are both negative. And in quadrant 4, cosine is positive. That means sine is negative, and so is tangent. Now, a little saying that they came up with is all students take calculus. or pre. That doesn't really work. All students take calculus. All, everything is positive. Students, sign is positive. Take, tangent is positive. And calculus, cosine is positive. You do have to know that saying. All students take calculus. It makes your life a little bit easier moving forward. So once again, all students take calculus. Yeah?
What's your favorite type of math?
Oh my God. Probably pre-calc. All right. We're going to skip these for a second. Let's go ahead and fill out our unit circle. Let's go ahead and fill out our unit circle. So on Monday, if I was taking this quiz, the very first thing I would do is the degrees. We're going to put degrees here, radians next, and our XY values here. Usually if I gave you a quiz, you would have a blank for all of, everything. You just basically got to fill in blanks. So most of these have blanks. Let's do degrees first. If I was doing degrees, if you remember, we're going to count by 30s first. So I would do 0 degrees. I would do 30 degrees. Then I would do 60. And then I would do 90. Then 120. Then 150. Then 180. And I always check at these points, am I correct? Yes, I'm correct. We're at 180. We have 90. This should be 270 when I get to it. 180 plus 30 is going to be 210. Plus 30 is 240. And then we're going to have 360. No. Right. No.
Wrong.
Yeah, you know you're wrong. We should go down to 270. So we should know those key points down there. Then we're going to have 300. And then we'll have 330. What's a quick way to get the middle ones?
Add 15.
Add 15. And that could just start by going, okay, you should know that middle one is 45 here. It's all the other ones that are a little confusing. 30 plus 15 is 45. 120 plus 15 is 135. 210 plus 15 is going to be our 225. And then finally we have 315. All right, I lied. That probably won't be the first thing I do. The first thing I probably actually would have done is I would have in the corner of this wrote like a 3, 4, 6. Because why not? Why not memorize those 3 numbers and immediately write those down? Those are the denominators of radians. So that can help not jumble everything up. That as soon as you get it, write down 3, 4, 6. So if I wrote down 3, 4, 6, now I just got to remember what order we do those in. Well, maybe you don't realize right away, so that means you do your key radian values first.
Yeah.
Your key radian values would be 0 radians. And then when you get up here and you're like pi over 2, 2, 3, 4, 6. That might be the signal that, okay, now I can figure out what the 3, 4, and 6 are. I'm going to go ahead and fill out the one way to the left, which is pi. And our bottom one, this is the hardest one. I also see people mess this up. This is 3 pi over 2. And I always remember it's 3 pi over 2 because this is pi over 2. This is 2 pi over 2s. This is 3 pi over 2s. You have 3 halves, so it's 3 pi over 2. And then we go, okay, 2, 3, 4, 6, 2, 3, 4, 6, and we do that on the bottom. So I have 2, 3, 4, 6. I have 2, 3, 4, 6. Then we go way down here and we go opposite direction. 2, 3, 4, 6, 2, 3, 4, 6. What goes in the numerator of every single radian? Pi. So now I do pi. And you might be able to do this all at once where you can go, quadrant 1 is, what do I have in front of pi? We just don't put anything or we put a 1. Second quadrant, what goes in our numerator for the numbers? 1 less. So quadrant 2 is 1 less. So if it's 3, it becomes 2. 4 becomes 3. 6 becomes 5. Quadrant 3, what goes in our numerators? It's 1 more. So 6 becomes 7. 4 becomes 5. And then 3 becomes 4. Our last quadrant is the hardest. Does anyone remember the rule for our fourth quadrant? Times 2, subtract 1.
So times 2.
Minus 1. So it'd be 6 minus 1, which is 5. And then we'll have 4 times 2 minus 1, which is 7 pi. 6 times 2 is 12, minus 1 is 11 pi. It's not bad as long as you kind of practice those rules and memorize those. And if you need to, as soon as you get the unit circle, just write those rules down so you don't forget it as you're writing it out. All right, now let's get to our sine and cosines. Let's do our first quadrant. So what I'm going to do is I'm going to already give myself places for points because my goal is to just fill in spots. I don't want to get distracted with having to put the points in the places. Here is the one point you have to have correct. You have to understand that this is right 1, up 0. So this has to be the point 1, 0. That has to be the point 1, 0. Now, the nice thing about sine and cosine, they're all fractions with a denominator of 2. So what you could do right now is put everything as fractions over 2. And now I have kind of a lame saying, but it's follow the sign. Like a road sign, you're going to follow this sign. You got to figure out which one of those values is sine and which one's cosine. Well, cosine comes first, sine is second. Follow the sign says start with your sign. Sign starts at 0 and you just count up. 0, 1, 2, 3. That's all you need to write. It's easy as 1, 2, 3. Follow the sign. It goes 0, 1, 2, 3. Then the cosine is going to be the opposite. It's going to go 1, 2, 3, or 3, 2, 1. Whatever order you want to kind of remember that in. It's just the opposite. If one's 1, the other one's 3. If one's 2, the other one's 2 as well. Now you just put square roots on top of everything. So we can put a square root of 3, square root of 2, square root of 2, square root of 3. Like I said, I do have students that put the square root of 1 because it's just in their minds to take the square root of all the numerators. That's fine. You can put square root of 1. That's the exact same thing as 1. What is this point?
0, 1.
0, 1. That doesn't really work with the whole thing, but we can go 0, 1. Yeah.
Does that mean the bottom row is 1 comma 4?
The bottom, this one?
Yeah.
Think about this. It goes left or right, 0. So it'd be 0, comma, negative 1. And we can go ahead and fill that in since it was brought up.
My bad. Didn't mean it.
No, good question. I'd rather you get that straight than on the test all of a sudden do that.
Yeah.
All right, here's a nice thing. I should have had. Let me do that a little neater. Okay, so we're going to have points here. And here's the good thing. If you got this right, it goes 0, 1, 2, 3. Now I'm going to continue with sine. It's going to count down. So sine goes 0, 1, 2, 3, 3, 2, 1. 1, 2, 3, 3, 2, 1. So I actually fill out all the signs first. I'll go around the entire unit circle and fill out all the signs. So that's what I'm going to do next. So it goes 3, 2, 1. Remember, they're all denominators are 2. So that makes your life a little easier. And then I'll go to the quadrant 3, and I'll just continue with sine. So sine went 3, 2, 1. It will count up. It will go 1, 2, 3. And then it'll come back down to 3, 2, 1.
And then you just put everything.
And then you put square roots on everything, yeah.
So with the signs, since it's a quadrant 3, would it be negative? Since it's on
Yep, and we'll get to that in a second. Yep, they'll both be negative. And I'll show you 2 ways to remember that. So remember that all students take calculus, or we can just read x, y coordinate planes too. All right. So let's put square roots on all the stuff I just did. You can put it on the ones if you want to. I don't, but you can if it helps you remember it. And if you had all of your signs laid out, cosine's really, really easy. if you have a 3 for your sine, your cosine is a 1. You just flip what's happening there, because it's either 1/2 square root of 3 over 2, or it's 1/2 square root of 3 over 2. So if I have square root of 3 over 2, my cosine is what? 1/2, or 1 over 2. My cosine here is going to be square root of 2
Same.
over 2, so it's the same. And the other one, if I have a 1, I have a 3. And then we go down here, and we have a 1, so that becomes the square root of 3 over 2. If it's a square root of 2, you just repeat it, square root of 2 over 2. If it's square root of 3, we change it to a 1/2. If it's square root of 3 over 2, it's a 1/2. Square root of 2 over 2 repeats square root of 2 over 2. If it's a 1/2, it becomes a square root of 3 over 2. Is it that bad? As long as you kind of follow that hint, start with your sine and go up. Yeah.
So we put the negative in the third and fourth ones?
Yep, we'll do that in a second. Yep. I'm also going to fill out this point. What point is this one? I go left 1, it's -1, 0. All right, now let's do our all students take calculus. I'll put an A in the first quadrant. That means everything's positive. I do nothing with it. Students, that's our S. Our sign needs to be positive. Everything else is negative. So that means cosine needs to have negative values in front of it. So all of the x values will be negative. I added them in red.
Just look at the.
Yes. Yeah, we'll do that in a second. I just want to do the all students take calculus, and then we'll do just look at it, right? All right, so we have all students take. Did we even talk about tangent yet? Nope. So tangent is positive. That means everything I just wrote is negative. So we'll have a negative, 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 negative. All students take calculus. So cosine is positive. So that means all of our y values or our sines are negative. Now, as two people already pointed out, if you forgot all students take calculus, you could just look at how an xy plane works. To get to quadrant 2, you have to go left, which is negative. Your y value is positive. So if I had a point right here that was like -1, 1, x would be negative, y would be positive. To get to quadrant 3, I have to go left and down. So they both have to be positive to get there. To get to quadrant 2, I have to go right, so my x should be positive, down, so my y should be negative. If you can follow those rules, it's way easier than having to just keep writing the unit circle until it's somehow memorized in your head. So I strongly suggest writing down how we did this and practicing that way. Questions on that? Okay, now that we have our unit circle filled out, let's read a couple values. Sine of 135. Now remember, to find the sine of 135, your job is to find 135 degrees. That 135 degrees points right to this point. So either it's negative square root of 2 over 2 or it's square root of 2 over 2. Which one would I pick? Would I pick the negative or the positive one for 135? I'd pick the positive one because that is our y value, so that's our sine. So it'd be a positive square root of 2 over 2. Let's do the sine of -7 pi over 6. We go to our unit circle and we find negatives. Does anyone feel like filling this out in the negative direction? Reed, do you mind putting that down? Does anyone feel like filling out their unit circle in the negative direction? Do you want to, on a test, have to fill it out 2 different ways? No. So what we're going to do instead is we're going to say, okay, Mr. Pabian gave me -7 pi over 6. Is there some way to turn -7 pi over 6, be in the same location, but make it positive?
Yeah.
What was that?
Yeah.
We're going to find a coterminal angle. How do I find a coterminal angle if it's in radians? I add 2 pi. So we're going to go ahead and we're going to add 2 pi. Adding 2 pi, we have to have a common denominator. So if you struggle with common denominators, what I do is I just write the common denominator first. I know it has to have a 6. And then I think about, well, 2 pi over 1. To turn 1 into 6, I needed to multiply by 6. And so I'm going to multiply the 2 by 6 as well. So that should be 12 pi. Are we okay with that? Which is going to equal 5 pi over 6. And then we just read the unit circle. It's okay. These were just quick examples. But that's basically what your homework's going to be, is reading the unit circle. It's either going to be really hard or really easy, depending on what you remember from last year.
Just this.
Yep, it's just that.
So